Okay, good morning, good afternoon, or good evening to all of you. I know we have participants from over 50 different, countries. Um, so I hope you are all doing well. Thanks for joining this webinar. Let me introduce the webinar series and then introduce the presenter. I know, I showed this presentation, in almost every webinar, but every webinar we have new presenters. So for their benefit, I just want to show this. So this is our webinar series. We have been having since mid-January. I can't believe it has been almost a year that we have been having these webinars, and it's on a very interesting topic of geoenvironmental engineering. It covers polluted land, waste management, and sustainability and resiliency. So we have been meeting every Friday here, and these webinars are intended to be helpful to graduate students and young faculty and postdocs in geotechnical engineering, environmental engineering, and other related fields. So we are on the last stretch. Today we have a very interesting presentation on confined disposal facilities for contaminated dredged sediments. And then we will have the last presentation next week. It's going to be given by me on sustainable resilient site remediation. So that would be, the last webinar for this year. And what we're going to do next year is not decided yet. I know people are very tired of webinars, so we will plan some other activities to, keep engaged and keep in touch. So good thing is all the past webinars have been recorded with the consent of the speakers. So we have this YouTube channel. We have over 50 recorded webinars on different topics. This will be a great resource for students or young faculty or postdocs. If you want to know, a bit more about any topic of your interest, or you want to, look into, different topics that you want to pursue. These webinar series, I started it with the purpose of having everyone understand, there are many geoenvironmental problems, not just, the, one or two topics that you heard, so also, learn what research projects are going on elsewhere from the experts, and also learn the research methodologies that these people are using it. And the whole intent is to help, graduate students, especially, to think about new ideas for their research thesis. And also wanted to create a network of geoenvironmental engineering researchers. So we have a good group of people together. So you can try to contact these people and keep in touch and ask questions. So that will have a lasting value. So geoenvironmental engineering is a very broad field, deals with waste management, mitigation of contaminated sites, this broad area of sustainability and resiliency. And it's not just a geotechnical engineering or environmental engineering, it's a combination of those two fields, as well as a lot of other multidisciplinary background that you need for these kind of geoenvironmental problems. So I always show how to write geoenvironmental engineering properly. And if you are a student, I would recommend you to look at these YouTube videos that provide you, a lot of information about what is geoenvironmental engineering is, what are the topics. I also found these resources, how to do the literature research, how to read a journal paper, how to write an abstract, how to write a journal article, how do you give a presentation. So this will be really useful for the students to view them. So today's webinar, this was like a couple of days ago when I looked at it. Today I saw, many more have registered. I don't have the exact number. It was close to 700, I think. Close to 570, I think. So please mute your mic and switch off your video, and type your questions in the chat box at any time during the presentation. And our presenter will answer at the end of the presentation. And thanks again for joining this webinar. So let me introduce today's speaker. Our presenter today is Dr. Mirko Felici. He received MSc in construction engineering in 2014 and PhD in geotechnical engineering in 2018. Currently, he is a postdoctoral researcher in geotechnics at the Università Politecnica delle Marche, known as UNIVPM, in Ancona, Italy. So he is involved in many research projects at this university, which are funded by different public authorities or companies. He presented his research at many conferences, both international and international conferences. So he's the author of several papers on different topics. His main research areas are geotechnical characterization of soft soils, soil improvement, building and monitoring of confined disposal facilities, which is the topic of today's webinar, dredging of marine sediments, and hydraulic behavior and contaminant migration through containment systems. So, many topics are really of great interest to geoenvironmental engineers. So with that brief introduction, I welcome Dr. Mirko to share his screen and let me stop sharing my screen and then so that he can start his screen and start his presentation. So welcome, Mirko.
Okay. Can you see the presentation?
Yeah, I can see it and I can hear you well. Yeah.
Good morning, afternoon, or evening, depending on which part of the world you are attending to this webinar. Thank you, Professor Reddy, for your introduction. Thank you, because with these weekly meetings, you're giving us the opportunity to share research in so many fields of geoenvironmental engineering. And it is giving us also the opportunity to discuss and sometimes it happened to me to widen the research program. So I would thank you for this. The topic of today concern marine dredging sediments and the role of confined disposal facilities in their management after removal from the seabed. A field that surely required a multidisciplinary technical approach proper of geoenvironmental engineering. In particular, today we will see how confined disposal facility could be considered a sustainable solution to sediment management. In particular, we will see why dredging is necessary and how it is possible to manage the large amount of quantity of waste produced. We will deepen into the confined disposal facility sustainability and the possibility of reusing contaminated sediment as filling material for reclaimed areas. Then we will see some geotechnical aspects involved in their construction and reusing. Finally, I will present a case study of CDF in Ancona Harbor, on which I'm working on together with the research group of Politecnica University of Marche. Maritime shipping is considered the most fuel-efficient mode of transport. It moves approximately 90% of global trade, and so it is vital to domestic and international commerce. It is also considered a relatively environmental friendly transportation that accounting for less than 3% of global anthropogenic CO2 emissions. Data here presented of 2020 show significantly upward for maritime trade demand. In this context, dredging is essential to develop and maintain navigable depth in ports, harbor, and coastal waters, as well as the development of port facility. In fact, the reason for dredging are principally the capital dredging and the maintenance dredging. In this context, moreover, we can cite that environmental reason could have a great importance when it is necessary to remove the material, for instance, in a former industrial site where the level of contamination is very high. Only referring from our little country, Italy, the estimated dredging demand is of about 130 million of cubic meters for these years. This is a huge number that let us understand how this problem could have to be considered as an environmental problem, and environmental issues. We see how the dredging project have to be developed. Particularly, preliminary characterization of the material to be removed has to be done in order to evaluate its environmental quality through chemical, physical, and microbiological analysis. Then we have to choose the most appropriate technology to the seabed characteristics and to the sediment contamination also. For instance, in case of remedial dredging, we have to use technologies capable of limiting the resuspension of the solid and consequently the bioavailability of the contaminants. Afterward, places of relocation and possible recycling on the basis of their environmental quality have to be provided in advance. Possible sediment management options depends on their environmental classes. In the box, you find the best possible use admitted from the environmental point of view. I see in Italy, for instance, quality classes from A to E are being identified on the basis of the before dredging characterization. A class is the most clean sediments usable, for example, for beach nourishment, and then there are no problem with A-class sediments. The B class have a very low contamination, and in fact, there is the possibility to discharge the material at sea in special areas previously identified. The negative sides of this practice are well known, and it can only be used where other option are not feasible at the regulation, at the actual regulation. In fact, the negative sides of the practice are well known and is too often abused, sometimes depending by lack of planning of management of sediments. From data collected in the last year worldwide, data, it would seem likely that the quantities of dredged material dumped in the oceans could be up to 1,000 million tons per annum. Frightening numbers. We must avoid as soon as possible dumping. So it's not considered in these schemes. C-class can be relocated in open water facilities or even for underwater capping. D-class have to be located in confined disposal facility that hold also the water part of sediments. E-class is the worst quality class. Sometimes it could be assigned to hazardous material to understand. Their removal should be evaluated on a case-by-case basis and according to the associated risks, site-specific. They have to be disposed in appropriate landfill, and they cannot be reused as they is. In the decision-making process, a fundamental rule is reserved to the possibility of recycling the sediment and carry out treatments to recover part of it or decrease its contamination. The goal, sure, is to transform the sediment into a resource by pursuing the beneficial reuse of as much as possible part of it. To this regard, an integrated approach of sediment management has to be developed. A sustainable approach to this problem should be similar, in my opinion, to that used for waste, with a methodic collecting and sorting of them, creating a range of facility waiting for the dredged sediment as resources to be treated and transformed in recycled material, or simply reused as is in confined disposal facility, for instance, or for a minor part disposed in landfill when it is inevitable. The goal, however, is to minimize the amount of material to be taken to landfill, and especially that to be dumped into the sea. To be done, we have to think an integrated approach that links the need of dredging with those of the coastal nourishment, urban planning, port facility development, and all markets and sector interested in recycled goods from sediments. For instance, construction material or agronomic, for instance. I think that a comprehensive approach to the dredging problem is justifiable in light of the large quantities involved and the volume of investment also that have to be done by administrations every year in continuous. So in this context, I would deepen into confined disposal facility rule and address the issue of the sustainability of their construction. First of all, because of high investment costs, in the CDF should be end up only the non-recoverable parts that usually have a medium level of contamination, non-hazardous, for understanding, and they are also fine-grained, that often the sediment that goes into confined disposal facility is fine-grained because they are less valuable than the coarse part. So in this way, they can become a sustainable resource, for example, in land reclamation project, integrated with urban exposition planning to create a new useful sites that should be surely integrated with the expansion of city and planning. To this point, a long-term program is required also due to long construction time of the CDF. The advantage is that the CDF remain available for manage multiple dredging operation with time, and in harbor context could be useful, for instance, to provide partializing of the CDF to have the facility available for sediment disposal during time, and in the meanwhile use a part of the area already filled. But what type of contamination we have to consider? Contamination level surely must be below than the maximum level associated with the intended use of the facility. In fact, for example, when we think to a green urban areas or an industrial ones, the national regulation in Italy, for example, but I think in all the country, give us different referment for the different referring for the reuse of this material, and for the maximum level of contamination associated with this intended use. This is very important because otherwise it could generate a paradoxical situation in which we need to perform a remediation in order to reuse the area after the disposal that have to be evitated, surely. Long-term monitoring, it's important, have to be done in order to guarantee the efficiency of the system in the long-term conditions. Surely. The geotechnical and geoenvironmental aspect of a CDF project are ensure that the impervious confinement guarantee performance request by national regulation. Namely low permeability natural or artificial boundary, lateral and the bottom, have to be at least equivalent to 1 meter of soil with permeability of 10 power to minus 9 meter per second. And organize the filling phase in function of the subsequent consolidation phase. And moreover, after disposal and sedimentation, dredged sediment have typically very high void ratio, so it is necessary to design a consolidation strategy to make the area usable. Finally, determination of useful information on sediment behavior is essential to design consolidation system and to provide a reliable prediction model. To gain the first goal, the typical lateral cutoff that could be done is made by, for instance, a special sheet pile barrier with joint impermeabilization, or by plastic barrier made by CB mixture. This last solution, have different solution for land side, where excavation could be made with round bucket or with hydromill machine. And in the seaside, the solution provides the two sheet pile wall with in the middle the CB mixture. CB mixture also could be used for bottom barrier of the CDF. This is a typical solution, but it's not necessary if in the CDF site we have a natural low permeability layer under layer. So if the geology is favorable, we can use the cutoff wall to create the bottom barrier with the sample a low permeable layer. To this regard, that the CB mixer used for boundaries of CDF, I would show you a research carried out by Professor Fratalocchi, who studied the possibility of reusing the sediments in a ternary mixture cement, bentonite, and water. A quantity of sediment up to 1.5 kilogram per liter of mixture was added to different types of mixtures and studied in a flexible wall permeameter by means of long-term permeation in tap water and seawater. We can see some results that show a good behavior of all the mixture in tap water, but we can observe an increase in permeability of conventional mixture in seawater. This not happen in mixtures with fluidifying additive, and for the patented product that continue to show good results even in the long term. When the CDF is filled and water is inside, we have to expel in the sea. For this reason, CDF are provided with floodgates. This operation could be a problem in presence of contaminated sediments that could be subjected to release of pollutant. It depends on the type of contaminant, sure, and the duration of exposure. In this context, water treatments could be necessary before proceeding to discharge the water. Management of water could be a serious issue in design of CDF, especially in case of hydraulic disposal that could introduce in the tank until 10 parts of water for each part of solid, to have an idea, in a very short time. In case of mechanical disposal, instead, the volume of water is much lower. So it's preferable when it is possible. Italian regulation is not very clear for the specific cases of water management. In different cases, we have found different approach from the different administrations. However, is always valid the respect of non-regressive principle for environment. So the discharge have to be done in a sure way. Okay, after the sediment management process, it is desirable, as I have already said, that in CDF is conferred the less valuable and averagely contaminated part of sediments, which are usually characterized by fine particle size. Therefore, here I present only some of the possible technology for the improvement of soil characteristics. In particular, I wanted to focus on two possibilities, the treatment before and the treatment after the disposal. In particular, the technique that allow at the same time to improve the mechanical characteristic of the sediment before disposal and to obtain a treatment that limits the mobility of some contaminants is the solidification and stabilization with cementitious binders or lime. It can be realized by means of an inline plant that processes the material before it's laying in CDF. In literature, there are some studies that have tested techniques with also sustainable cement. That is very interesting for the issue. On the other hand, we have after sediment disposal treatments. I present the preloading, that is the most important techniques for fine-grained sediments, suitable and the most suitable techniques. Yeah, it could be performed also by vacuum or by embankments, coupled with prefabricated vertical drains. Possible treatments in site for the contamination to be coupled with preloading could be electrokinetic remediation, bioremediation, for instance, bacterial and fungal treatments, or phytoremediation. It is very interesting to study the combined effect of these remediation treatments also on the mechanical and hydraulical properties of sediments, and to see if they are some effect on the global behavior of the soils, of the sediments. We go into the case history, where I want to present the case of the Ancona administration that some years ago proposed an integrated sediment management at regional scales that try to connect the supply, that is the sediments to be dredged in the different ports of the Marche region, and the demand of the land, of the territory, in particular the coastal nourishments and the needing of the ports of the harbor of Ancona, of a new container stocking area, land reclamation for a seafront of the city of Ancona, and the new cruise ship port, always in Ancona harbor. This is a good example where the administration try to give all the funding available to anticipate the problem of dredging and the necessity of the territory. In particular, a preliminary characterization of sediment to be dredged of every port of the region have been done for the assessment of sediment quantity and quality, to create a sort of sediment bank on which the territory can take the supply, the goods, the necessary sediments to create a new site, or to or for instance coastal nourishments. In this context, the container storage area have to be think as a CDF situated in that are placed in Ancona Harbor, that have an overall capacity of 300,000 of cubic meters, and that will be filled on over several months with the sediment from the nearby ports. The bottom boundary of the CDF in this case is done by a sheet wall pile that intercept a low permeability stratum at a depth of 20 meters, about 20 meters. Lateral boundary is done by a sheet pile that that in the joints have been done impermeable with an hydroexpansive synthetic resin to sealing the joints, moreover, an electrical system called Dixran is being used to verify the continuity of the sheet pile with depth. That is another issue of the technology. The results was very good, and to verify the impermeability of the CDF, the facility is under monitoring by a web-based weather station that records the parameters in continuous. The comparison between the increasing of the internal water level and rainfall level show total agreement, as shown by left and central side graph. You can see, okay, there, and also it's possible to see that the higher evaporation happen in summer, as we can see in the central graphics that show the data from July to September. Another important comparison between sea level with CDF internal level is reported in the graph on right side, that show that there is no relation between these two levels. In fact, when the sea level is upper than the CDF level continues to decrease due to the evaporation phenomenon. So I think that we can say on the basis of this observation that at the moment the CDF and the sea are independent hydraulic systems. However, monitoring will continue throughout the CDF live, so we can see in the future if the situation remains the same. I want to say that the monitoring is an open access website that is free access from every users. So if you want, you can see the situation of the CDF of Ancona whenever you want. As I have said, the filling of the CDF will be staggered over several months or years. Therefore, an internal partition in sectors of the CDF was planned for managing the filling steps and the subsequent sediment consolidation. The adopted solution for the creation of the sector is a special geotube filled with dredged sediments. In the image, you can see the confining of the first sector of geotube and its filling. We have choose this kind of solution because when we have done the first disposal of sediment, we have observed deposition angle under 10 degree. So for use the area for apply consolidation system, we have to confine a sector of the CDF and try to apply consolidation system. This solution of the geotube has been chosen because it could be filled with dredged sediment, and so it could minimize volume loss into the CDF. It has been effective during the filling of the sectors, as we can see from this image, and there hasn't been no instability of the geotube at the end of the filling. The consolidation strategy chosen for the reuse of the area has been the preloading by embankment coupled with the prefabricated vertical drains. The advantage of the reason why we have chosen this strategy is that we have the availability on site of material for the construction of the preloading that has been recovered by demolition of docks and port buildings during the CDF construction. So this material give the opportunity to be used as a moving bank that after the geotube placement and the disposal of sediment in the first sector, as we can see in this scheme, the consolidation of sediment in the first sector could be done, and simultaneous we can fill on the second sectors. After we can then we can consolidate the second sector, and finally we can proceed with the consolidation of the geotube area. This procedure could significantly reduce the risks of instability in the zone close to the geotube. So it's important to not go very close to this structure, because when we apply a high preloading, it could be dangerous. With this procedure, we could significantly reduce time to get the CDF ready to use for its intended use, for a part of it almost. And after the filling of the sector, we decide to use the first sector as a test field to set up the operating procedure, firstly, to verify the efficiency of the chosen strategy, and also to evaluate the real consolidation time and, by consequence, the embankment waiting time. a huge laboratory investigation was conducted on the sediments disposed in the first sector, which were characterized by predominant fine-grained composition. Odometer and consolidometer tests have been carried out to investigate compressibility and permeability of sediment, and there is reported some tests performed. For further details, you could refer to the reference paper. An important part of the research is establish the hydraulic conductivity of the sediments. As we can see, there are a spread of the results deducted indirectly determined by odometer tests, and we have sorry, I have some problem here. Sorry. And we have done some new tests with their direct measure in rigid wall permeameter that show that that odometer test tends to overestimate at height void ratio the hydraulic conductivity. A very interesting research is being carried out that study the compressibility and also the hydraulic conductivity of material when sediments have been used used for treatments, for example, for bioremediation with bacterial and fungi. Preliminary results of this research showed that there are no significant difference in the compressibility. That for this kind of material is not results is not obvious results when this, for example, there are the organic matter in the fine-grained sediments. So I can't let to see the results because it's not published. So I want only to anticipate these results. An in situ investigation survey has been carried out to investigate the correct stratigraphy under the test field area and to estimate the mechanical and hydraulical parameters. The table summarizes the value of the main parameters assumed for the consolidation design. And we can see how the dissipation tests have been used to estimate the horizontal coefficient of consolidation. The field scale test design has considered a stratigraphy with a coarse material that is useful as upper drainage and sediment, fine-grained sediments of about 6.7 meter that are the compressible soil. A dense sand of about 8 meters depth is considered as a lower drainage to have the double drainage conditions This is possible because the stratum of dense sand is continuous for all the CDF. Test field dimension is of about 30 meters, and this is be done to consider the one-dimensional deformation conditions. The service load is of about 46 kilopascal kPa, and the design variable is the design variable considered is the pressure to be applied by embankment and the waiting time and the spacing of the draining mesh. And establishing the pressure to be applied, we have estimated the waiting time with different spacing of the draining mesh, considering a pressure of 66 kilopascal. We have considered not an instantaneous load, but that we can see in that showed in the graph with time. Tange-Onitsuka theory of consolidation has been used to estimate the consolidation time. It considered radial and vertical flow in equal strain condition, and consider also the SMER time-dependent loading, sorry. The SMER parameters has been established according to literature, and the bench-shaped PVDs has been considered. The consolidation degree of reference is of 80%, and with this condition, we have found the results for 1 meter spacing and 1.5 meter spacing. According to port authority, we have decided to use the spacing of 1 meter to reduce the time of consolidation. The field scale test has been set up with monitoring instruments, and this is the results of the preloading. We can see we have the pressure cell to measure the load applied by embankment, 5 driving piezometers to measure water interstitial pressure, and 10 settlement gauges. We can see the preliminary data monitored during the field test. The results are not available on today because is to be published in a few days. So I can show you today. I finished. I have some concluding remarks. Particularly, we have seen that the sustainability of dredging activity necessarily pass through the integrated management of sediments. Due to the quantity involved and due to their potential beneficial reuse, sediment management would deserve a global approach that we have seen, the collect and sorting, for example. The CDF could be, in this context, an excellent opportunity to use contaminated sediment as a sustainable resource for land reclamation sites. Due to the long construction time, a long-term scheduling is required. The case history showed that to address this need, sectorization reduced time for the provision of the part, and it could be a good strategy to give a part of the CDF for its intended use. The level of contamination in the CDF is well known when we use medium contaminated sediment, and in case of any issue, the advantage is the possibility to implement remediation treatments in a confined environment. By researcher to researchers, we can see how the CDF could result a great opportunity to make research on field scale, for example. So it is very important for us in this year, for example. The technology about the field test and the CDF of Ancona, we can see that the technology used for the construction have resulted nowadays effective according to the monitoring data. Also, the sectorization with GeoTube is result sustainable in terms of saving CDF volume. The realization of the test field, finally, has allowed to verify the effectiveness of consolidation strategy chosen, showing that with the configuration adopted, it is possible to consolidate the sediment in about 2 months. That this time has been respected as the data have been demonstrated. Moreover, it has provided a useful indication for the programming of the operative sequences. That is very important when we we have to manage this kind of materials. Okay, there is some references and the acknowledgement of the. I want to thank the research group of the university and our funding partners. Thank you.
Very good presentation. You want to stop sharing the screen, Mirko?
Yes.
Yeah, I would say, like, really, fascinating presentation. I have been always saying that, we should get involved in geoenvironmental research. And your presentation is an excellent example of, what kind of a geoenvironmental problems that, needs to be addressed. So, in addition to geotechnical research or environmental research, your presentation covered a lot of geoenvironmental issues that I have been telling that we should be pursuing. You have covered containment, beneficial use of sediment, remediation, sustainability, all these issues to cover based on the lab testing, field testing, modeling. It's a very, very fascinating presentation with so many things done, in order to, solve the real problem. I think this would be really, really useful for all the young professionals to think about, challenges in geoenvironmental engineering and take up the research on this one. So overall, Mirko, excellent job. I mean, I really appreciate it. And your slides are so good. I mean, and you have provided so much of information. I think, thanks for allowing us to record your presentation, and think people have to go back and, review the video multiple times to, get all the things that you talked about. Maybe they can contact you for additional information if they need anything, publications or other things. So I want to congratulate you, and I want to thank you for taking time and sharing your comprehensive research with us. I learned a lot from this one. I know the sediment problem is there everywhere, right? I mean, especially the coastal areas, along the lakes, along the rivers, and this is not a problem, unique to where Mirko is staying. It's a problem in the United States. I know, it's a huge problem, and all over the world, it's a problem. If you live along the coastal areas, this is a huge problem too. So I hope, attendees can take away a lot of things from here and then, apply, to their situation, what can be done. And a lot of, interesting research, creative ideas can be incorporated into these research projects. So with that comments, Mirko, you want to say any comments before I stop recording, and then we take the questions? So you want to say anything?
Thank you very much for your words. I think that is a huge problem, as you have said, and it is too much under considered sometimes. But the quantities is very high, the quantities of sediments. So I think that have to be address a solution, a global approach to the problem, as I try to say in my presentation.
Yeah.
Thank you very much.
Yeah, thanks. And then, do you want to see the chat box and look at the questions?
Yeah.
Thank you.
Yes.